G'day everybody and welcome back to the channel. I wasn't going to do another video until I got the rest of all my parts ready, but I've actually got a few things to be doing, so I thought I'd just do a quick update video on what's going on. So these output stages that I have to change the drivers on, I've decided now that I've got full size resistors, these are from Jaycar, these aren't, let me rephrase this. I bought some from AliExpress that have got steel legs and they look cheap, and I've got some from Jaycar that have got copper legs and a nice quality. The inductance on these is 0.008 millihenries more than, I think it's millihenries, yeah, than the mini resistors. And I've done research, a lot of research on resistors, and I think I might have explained this before, but the reason this amp's a mixture of metal film and carbon film, like this, is basically what I've done is all the low value resistors that are in the BIOS network, Zobel network, power rails, stuff like that, they're metal film. Resistors in the feedback network and in the input stage that are high value, they are metal film because carbon film resistors have more resistor noise. Metal film resistors, they're also less inductive. Metal film resistors are more inductive, but they have less noise and they're more precise. So I've had a good think about what type I want where, and I've gone through the whole thing and done so accordingly. And I've decided to make a few changes to the output stage. I mean, by the time I finished designing the input section, I've gone for some really high quality parts in here, and I've spent my time designing the input section, even resistor choice, transistor choice. I've picked really good transistors, quality components, quality capacitors, nice transistors. When these TIP 41s come out, I'm putting in some really nice, Japanese driver transistors. So I thought I might as well go all the way with it. I'm going to change these Mylar caps in the Zobel network for these MKPs. A lot of people fear that if they use X2 MKPs in their amplifier, that due to the self-healing feature on these things, that the capacitance value will get smaller over time. I'm here to tell you that that's not the case. So the way these work is when a spike comes in that's above its working voltage, say a 300 volt spike or something even above that, and it goes to form a short inside and jump through the dielectric and arc over, that's when it just blows a little hole, melts back and stays open circuit, the self-healing. That's not going to happen in an amplifier. Have a really good think about it, because I'm not having a go at you guys that watch my channel. I'm not saying you guys are responsible for this. Let me just rephrase. I'm sorry. I've read so many people on forums saying, oh, I can't put this in my amp because of the self-healing. It's going to diminish. I just lost my mind thinking about that. If you have a think about it, no, that's not going to happen. Also, try and put MKPs, oh no, not this capacitor, it's another capacitor I'm thinking about. Anyway, never mind. I was going to say the size of them is good too, but anyway. So yeah, I chose bigger ones, 275 volt, just purely, and these have got a really low dissipation factor too. Here's the thing. Due to the size and the quality of them, these are going to dissipate power way better. I doubt anything's ever going to happen to them. Well, they can't fail short anyway, but I doubt that would ever happen. I doubt they'd even, try and blow a hole. There's not going to be those sort of spikes present. So I've decided to go for MKPs instead of those. I've decided to change the 2.2s and the 10 ohms. This is on both output stages. I've got the other one just here, just off to the side. I've decided to change all the resistors to full size ones. Honestly, I'm not going to lie, it's a bit of a look thing. I won't lie. Honestly, these little, it's a bit of both. I mean, these have got slightly higher inductance than these, but these should theoretically have less current noise, Johnson noise or whatever it's called, than these. So, because of the larger size. So, yeah, you're not going to really get current noise picked up in the driver and output stages because it's not a high impedance, high gain section. But anyway, I've decided that that's what I'm going to do. The main reason I put carbon film, incidentally, in the output stage is to lower the inductance, because where you've got current flowing, that's the worst place for inductance. And yeah, pretty self-explanatory, isn't it? So anyway, you get the idea why I've used a mixture of resistors through this amp. It's to minimize inductance and noise in various areas. Now, something else is going to arrive. Well, let me just go over this first. I've decided to change these metal film resistors because they have inductance to them. Everything has inductance, but these are more inductive than these. I've decided to change these 2 watt 4.7 ohm resistors to 2 1 watt 10 ohm resistors in parallel. Be 5 ohms, good enough. Just less inductance, that's the only reason. Okay, now let's get on to things that I've ordered. I've decided if I'm going to change that, I'm going to change that. The coils are already nice, big, wide air coils with a good Q factor. What's the one component in this network that still isn't being upgraded? It's the wire wound resistor. So what I did is I ordered some of these low inductive resistors, 4.7 ohm 5 watt, to replace them. They haven't arrived yet, but I'm just letting you guys know. Everything, I'm going over everything with a fine tooth comb and just taking it as much as I can without it being ridiculously expensive. It's already ridiculously expensive, but I don't want it to get into silly terms. I mean, it depends what you define that as, I guess. There are people that spend $50,000-$80,000 on an amp, you know. That's what I define silly. So yeah, anyway, so I'm waiting for some non-inductive 4.7 ohm resistors to swap those out. The other thing I've done is, I'll just get the schematic open here so I can show you exactly what I'm talking about. In the feedback network, there are, I know this is very hard to see, I'm going to read through all this. There's a capacitor there, and a capacitor there, and a capacitor there. What I've done is I've ordered those capacitors are 470 picofarad, 47 picofarad, and 22 picofarad. I've ordered them in polystyrene. I'll just go grab some because I've already got some. I can show you what they look like. I just don't have all of them. I've only got, out of all the values I need, I've only got the 470 picofarad polystyrene caps. I've got a couple, but yeah, I don't have the 47s or the 22s, so I've ordered them. So really high quality caps in the feedback network. Now, there's still one other thing that I still haven't solved. So as I mentioned in yesterday's video, I ordered these by accident, and guess what? The rest have arrived. I cannot believe I did this to myself. And these aren't cheap. Oh, man. I should have realised the price, but I just thought, like, Weimer capacitors are expensive. I just really wasn't thinking that day. Anyway, like I said, I can't blame anyone. I did that. So, I've got 250 volt MKPs. Really low dissipation factor, good ESR. They spec well. I'll show you the problem with those. So, just to put that in perspective, it is half the size for half the voltage, but or under half the voltage, but it's actually a third of the size. right? So that is a much better option. However, in the grand scheme of things, bearing in mind that this is the bias stability capacitor and needs to be mounted across those two pads, two of them. You know what? We might end up doing that. It's going to look funny. So I'm tossing this up. I only have a couple of MKS4s, not enough. Like, I don't have a pile of like 4, 8 or 10. I've only got like 2 or 3 in the box. So I've ordered 10 MKS4 4.7 microfarad at 63 volt. And I've got plenty of these 4.7 MKP 250 volt caps that I just showed you. I've actually got 2 different brands of them. These both came from J-Car, but anyway, one's slightly bigger. Anyway, the toss-up is whether to use the MKS4 for the bias capacitor or to use the large MKP. Now, I am aware that you can order MKP2. Wema make a smaller capacitor called MKP2. I kept running into problems trying to order it. I can't remember what it was. I think everyone I could find on reputable websites, like Farnell, DigiKey, all that sort of stuff, they were only X2. Not that that's a problem. And then when I looked everywhere else, they looked like MKS. I can't remember. I don't think they make them in the value I want. Or maybe it was size. You know what? I'll pause the video and I'll have a look now. Because I've gone blank here and I feel like an idiot. I'm just mumbling, trying to think what it was, and I really can't remember. Let me go have a look. Sorry. Alright. So they don't have MKP2 in that sort of size, and they're physically too big in other styles. That's the problem I'm running into. So I'm either going to put MKS4 in there. This is an MKS4 cap. This is a 2.2 microfarad. The dissipation factor on this one's 0.003. I mean, that's 2.2. If it was a 4.7, it's probably going to be even lower because there's going to be more rolled up in there. So I'd imagine that it could be like 0.001 or 2 or something like that. It might even be unmeasurable. Let's see what the ESR is like. So that's 0.28 of an ohm at 1 kilohertz. Okay, this is a much larger capacitor, so this is obviously going to be different, but just for comparison, the MKP, it's 0.01, right? Way lower. But if we go compare against, say, okay, this is only 0.1. That's not really a good comparison. Let me go see if I've got any MKPs that are at least in the microfarad range. Alright, I don't. That's alright. See, the MKPs, the dissipation factor is always zeros, unmeasurable. The ESR is really nice on these as well. This is 100 nanofarad, bear in mind. At 1 kilohertz, it's 1.15 ohm. 10 kilohertz, 0.02, 0.00. Unmeasurable. I mean, they're just wonderful. 10 kilohertz, yeah, 0.06. So I'm just going to use MKS4 for the bias capacitor. Honestly, if you think about it, I don't think it's worth putting an MKP4 capacitor. Did I just... Oh, there it is. An MKP4 capacitor across the bias string. Because if you think about it, you've got diodes, normal diodes, not Schottky diodes, so they've got switching noise. You've got inductive resistors in the middle of it, and a whole string of diodes, right? do you really think putting the world's expensive capacitor across that is really going to make that much of a difference when you got this in parallel with it? I don't. I think this is going to cause more distortion and linearity effects and stuff like that. The capacitor's going to not make a difference to other stages where there isn't a network like that. Yeah, I've put MKPs there, but I just feel that this is sufficient for where it's going. So we'll see. When they come, I'll have a think about it when I make the board up, and I'll sit there and I'll do these ones, you know. I'll go, what do I want? And, you know, I'll put what I want there. So, yeah. Other things that I'm still waiting on to arrive that I've already ordered but are stopping me from getting the boards done. 100 mic, 100 volt caps, UF 4007s, drivers, and C1845s. Now, when the amp's done, what I want to do is I want to add some more stuff to it. Safe operating protection circuitry. All these things will be add-on boards that will be built around the amp, because like I said, this amp is getting built to do a bit of research with. I want to build high-end amps, and I want to do some experimenting with this design and see what works better. And once I've done that, then I want to experiment with some of this stuff: safe operating area protection, speaker protection, you know, DC protection, linear positive negative regulation on the plus and minus rails for the driver circuitry, input circuitry, better current sources, all stuff to look at coming up. So it's going to be quite interesting. And then eventually, once I'm done playing around with the amp and playing around designing those circuits, I'll end up making professional boards up, you know, like through PCBWay. I'll end up combining into like 2 or 3 boards, you know, like one long strip for the drivers and the outputs, one long strip for the fast and input stage, and then maybe another little board for fan control circuitry and stuff like that. I don't know. I haven't thought about it yet. Might all go on one board. I don't know. No, I wouldn't put fan circuitry on the same board as my audio stuff. But yeah, so that's what's happening. So what I'm going to do now is I'm going to whip all these things off that I want to change them, and then I'll bring it back and we'll take a look at it. Well, the rest of the transistors came today. I've matched them all up, and now I have 4 lots of transistors for the current mirrors. So I've got everything now. I have input pair, input pair, input pair, input pair, 23200s for one channel, 23200s for 2 channels, 23200s for another 2 channels, 2 lots of current sources for 2 channels, another 2 current sources for another 2 channels. Same thing here, 2 VAS transistors, 1 for each channel, another 2 VAS transistors, 1 for each channel, and then the 2 matched sets for the pre-drivers, or whatever you want to call them. Look at all of that. You know how many bloody transistors that took? Oh man. I'll tell you what, when you want to do a really good job of something and you want something to be really nice, it can take a bit of work and a bit of acquiring parts and a bit of patience and whatnot, but you know, the end result will be that I will have an amplifier that I really like and will probably use for the rest of my life. So in my mind, it is very worth it. But I will say, it's not for the faint-hearted. That is a lot of transistors. And yeah, like I said before, I didn't have to match all of them, but I would rather they are matched so that I don't have differences between channels, differences between amplifiers. You know, I want everything to be equal. So I finally have all of the TO92 transistors for this build sorted out after all this time. And some of the drivers have arrived too, which is really good news. I have finally got real, not fake, MJ15033s and 15032s, which are what I will be using as the drivers in this amp most likely. So we're just waiting on some capacitors now, and I have to fit these parts that I've just shown you to the heat sinks. But once that's done, I will be building my amp, or should I say amps, but it's in the one box. Might as well give you a quick look at the new parts. So these are the fake ones. They're all just in the one box now. These are the real ones. I've already pulled one of each apart. That's why I've only got 9 left instead of 10, but I've ordered more of them. I only ordered 10 of each just to make sure that they were legit. I was pretty sure, like I said, because I'm only ordering stuff. You know, I've done enough research, if that's what you want to call it, to find what places to go to for real stuff and what places to not go to for real stuff. I'm not sure what brand these are, but these are a legit brand. They're not a dodgy part. So let's have a quick look and see how close they are. I might have to wait for more to come because I do want them to be fairly closely matched. If they're a little bit off, I'm not too worried. It just depends how much. So they're about 100. Okay. It's I like them to be within 10 HFE at this size of transistor. I guess I still have to wait for capacitors anyway, so I think I'll just wait for now. But anyway, we have the goods. The goods are arriving. And I have quite a nice little pile of components that are building up here, from the resistors that I've carefully selected to transistors I've carefully selected and everything else that I've carefully selected. So this is going to be a nice bit of kit once it's done. Might be taking a while to get there, but it will certainly be worth it. I ain't putting any rubbish into this build. Alright, I know I already mentioned this earlier, but I've been doing some thinking and I've just added a few little notes. Obviously, I'm not going to do any of this until the amp's up and running, because it would just be stupid to add stuff when the amp's not even complete. But before, I was talking about adding safe operating area protection, speaker protection, regulation for the driver, VAS input area, stages, sorry, and better current sources, or, well, actually I've added to this, so that's what I want to go over. Regs, I had reg before, I put regs because what I'm thinking is all the positive, negative rails that go to the lower current stuff, obviously definitely the input stage, current sources, all that, but I'm thinking maybe the VAS as well. I want that to run off of a regulated supply. The other thing, before I said better current sources, I'm thinking maybe keep the same single transistor current source, but give it an external reference. So just for some food for thought, and you know, a little bit of a preview of what's going to come up after this is done. Next thing that's happened, I've finished sorting transistors. The rest of the transistors I've ordered that could be used in this amp have arrived, and I've sorted through them all to have a look at what I've got, and I actually ended up changing transistors from this build. So there's a couple of things to go over here. The current mirror transistors are still C1845s, but the VAS transistors, my apologies, my phone was low on battery. I don't even know why it stopped recording. I shouldn't have done that anyway. So 1845s for the beta enhanced driver transistor, and the VAS transistor itself is now a 2SC3790. And the current sources, are still the A1024s for the input stages, but the now larger current source that will be driving that transistor is its matching counterpart, the 2SA1480. So got some different sized transistors in those bags. I'll bring the data sheets up on the computer and show you why I've done this. And the matched sets for the pre-drivers, buffers, whatever you want to call it, those are 2SD1609 and 2SB1109. I guess I don't even really need to bring the data sheet up. I can just explain to you why I've done it. So the driver transistors, pre-driver transistors I was using before were a little bit small for the job and they would have run warm. So I thought I'd move up a little bit. However, the thing with these two different sets of transistors, the current source fast ones I've added and this matched set, they both have a fairly high FT, small cob, and I've chosen one device that's a little bit bigger than the other, but they're still fairly small. In fact, one of these devices, the die is basically the same size as the die in this transistor here. I haven't opened it up, I just know based off of the cob and the power dissipation and all that sort of thing. So transition frequency, there's a few things that are a giveaway there, but yeah. So they're actually chosen for the job. They look bigger than what they are, they're still quite small transistors. But I've got really nice transistors here. I've basically gone for quality over everything. The same with the output stage. I was actually thinking about, whilst I get it apart, to change these drivers to the MJ15032s, MJE15032s and MJE15033s. I was thinking about even putting 200 watt outputs in there, but when I think about it, going to a larger output device is actually not going to help THD. It's only going to help output power. So I think I'm happy with the 150 watt devices that I have. I don't want to increase the cob and all that sort of thing, lower FT anymore. So we'll leave them. What else? Okay, so I'll just put this off to the side. I'll pack that up in my own time. I'm happy that I finally have all the transistors sorted for the thing now. So some more capacitors have arrived. So I've got these really nice 100 microfarad 100 volt Nichicon capacitors. I have some 220 microfarad 100 volt Nichicon capacitors. These are FW series, FWM. These are VRM. The 47 mic caps, all I have at the moment is these shitty Chongx ones. You know what, I haven't checked them yet. Let's have a look at what the ASR is like, because if it's absolutely atrocious, I mean, it's not too critical. All these are doing is buffering an LED for a current reference. It's sort of providing an, what do you call it, a AC ground point for the current reference. So they're not critical. Oh. Yeah, these are actually good. I mean, they're small on the capacitance. I'm not happy about that. I mean, I am at 1 kilohertz. Let's see. Yeah. You get what you get, you know. You know, I bought everything that was cheaply available that looked half decent, and a few cheap things to replace what I couldn't get that was decent when I did my last shop on AliExpress. And I think those 47s and maybe one other value were the only value that I bought. I think there was a couple that I bought that were cheap, but all the rest are nice caps, as you can see. Oh yeah, and the other thing that's arrived is the ultra fast diodes, the UF4007s. It's probably these, yes. So those have arrived as well. Don't think I've added anything else to this bag, no. So we're just waiting on polystyrene capacitors and some MKPs and MKS capacitors to arrive, and then I'll choose which one I'm going to use for the bias capacitor. The polystyrene capacitors are for the feedback network, so they might arrive even tomorrow. I really thought a lot of this stuff was going to arrive by now, so this is really not far away. Oh, and I have some low inductance resistors, these style, coming to replace those with. So hopefully over the next couple of days all those parts will arrive and I'll be able to get this finished. But like I said before, what I'm going to get on with now is these parts, namely the resistor change, capacitors, and the new drivers. So I'll be back soon. Alright, here's something else I wanted to get on camera. So I was saying before, these MJ15032s and 15033s, the HFE's off by 20, and I wish they were only off by 10. I mean, I wish they were perfect, but I'd like at this size of transistor for them to only be off by 10, but it is what it is. However, this only tests at 5 milliamps. Now, at 1 to 5 milliamps, you don't see very much, but over 10 milliamps, they behave a bit different. And this tester, which I'll be doing a review video on soon, shows that. So if I set it to 10 milliamps and look at the HFE of the NPN, it's 82.6. If I set it again to 10 milliamps and look at the PNP, it's 75. That's only a difference of 10. And the way these devices are manufactured, they're designed to be quite linear as a complementary set. So as the current goes up, that's only going to be more linear. And where they are in the amplifier as a driver, they're going to be, you know, subject to current, a bit of it. So these are going to do perfectly for drivers. They are more matched than what they seemed. Let's just leave it at that to keep it simple. I am going to do a video on this. You know, it does a lot of the same stuff as what this does, but it also can supply 2 amps of collector current for VCE saturation test. You can select for the HFE test between 10 microamps, a milliamp, and 10 milliamps, which is quite useful. You can also do voltage breakdown tests. Quite useful. So there you go. This has its place too, don't get me wrong, but it can't supply as much current, so it's not so telling. Now, both of these devices are only good for transistors up to about this size. You know, does this show more for a power device? Yes, you know, but only for, say, you know, VCE SAT tests. You've got to remember the maximum base current it can supply for the HFE test is 10 milliamps. It's getting into the window of being enough to turn a power transistor on, but it's nowhere near, you know, what you want to look at the HFE as it goes up. And the same with the collector current that's being supplied across it. I don't know what that is. I think it's a bit, but yeah. Anyway, so it's useful, but moving forwards, we will be using a curve tracer. That's something I've got to finish building. Alright. Another additional thing I've decided to do with carbon film resistors is where our input here goes to 0 volt, it's actually going to have Well, here's the thing. I haven't decided what I'm going to do here, if I'm just going to have a resistor to ground or if I'm going to do a resistor and a capacitor. I haven't decided upon that yet. But where these 0 volts get connected together, they'll go to ground but via a 10 ohm resistor. So I just wanted to point that out. I've put some resistors in the little resistor kit here for that and off to the side, but that's where they're going to go. I will draw it in the schematic so that I don't forget, and we'll keep going like this, if that makes sense. I've done a little bit of thinking, and after some consideration, this is because of two reasons. One, the resistors are just too hard to get to in there without taking everything off, all the transistors out, the boards off. You know, I could do it, but you know, it's a pain in the ass to get to them. Other thing is, like I said in the first place, the smaller resistors sort of act like a bit of a fuse, potentially saving stuff further back. So I think I'm just going to leave the small resistors in there, but I have put the 15033s and the 15032s in here. So I'll now do the same on the other heatsink, and then we'll continue. These counterfeits are so weak that one of them actually crumpled into two pieces just taking it off the heatsink. I couldn't believe it. I just couldn't believe it. Anyway. Alright, that's all the transistors fitted. So mine's the scratches. I had to sort of use this tool and get it in there to do the nuts up, which was a bit awkward because a lot of this heatsink's threaded, so there's screws and nuts going in all directions. But anyway, I managed to get them all in there. They're fitted, soldered in place. I've still got to clean all the flux residue and everything off. Something I noticed is I haven't run the wires from the emitter terminals, or the end of the resistor banks, over to these pads. So I'll get that done. But before I do that, I'm going to get on to these components here. I think those resistors are going to arrive tomorrow, but I do have the capacitors here ready, and I do have the two 10 ohm resistors to make up 5 ohms. So I can at least get that done. And once that's done, hopefully the other resistors will be here. And in that order, I'm hoping that my 4.7 mic MKPs, MKS, whatever I choose out of the two that I got, and my polystyrenes will be here too, because as soon as they arrive, we can start building the rest of the amp. It's all just waiting. Alright, that's the resistors and caps installed, so that's what it looks like now. I still may end up going in and changing these resistors for the bigger ones. It's just, it's a pain in the ass to get to them, so I think I'll leave them. Anyway, that is all the work I can do today. The transistors are all installed, and the caps and resistors are done as well. I'm not sure if I mentioned this before, but I added that little link in that was missing for the BIOS networks on both the amps, because that would be a nightmare for one channel if that was missing on power up. Alright, that is that for today. Hopefully in the morning I get more parts and I can continue building these amplifiers, because that is what I want to do. I've been thinking about something else, and I want to discuss this too. It's these resistors here. I was considering putting carbon film in there to have less inductance, but the thing is, to be quite honest with you, I think I might have mentioned something about this before, but you know, with the audio frequency across the diodes might make a little bit of noise. I don't know, they should just stay, I mean, because switched on all the time with the bias, but I don't know, the audio frequency running through might create a bit of noise. The length of this circuit's going to have some inductance to it. The other thing is there's going to be a really nice quality capacitor across the bias network for stabilization, which is going to dampen ringing and noise and inductance and things like that in this circuit. So for that reason, I think I'm just going to leave them metal film. I think it won't make a difference. Yeah, but I just wanted to touch on that. Something else that I forgot to change over to, for the initial build with, all real components and proper voltages and all that sort of thing, this 150 ohm resistor that I had on the negative feedback that goes to the 1000 mic cap to ground, that's going to be, let me think about this, 15k. Let me just do some quick math. I'm going to make it 750 ohms. Might end up making it, 820, 1k, something like that. But for now, 750. I'm trying to think about frequency response too, not just gain. But yeah, we don't want too much gain. So I'll go get those resistors and put those in the bag as well. I've probably put 150s in there by accident, so I'll get that sorted. Alright, I did the math on it, and if I had 15k and 820 ohms, sorry, let me just start off. I didn't have a 750 ohm resistor in this size in carbon. In another size I do, but not this size. So what I decided to do is go with 680, because 820 ohms would only be a gain of 20. I wanted a gain of about 25. So we'll go with 680. That should be closer to 25, 26, 27, something like that. But that will be a good amount of gain. The output needs to be around, I think it was 33 volts, something like that. So a gain of around 20 something, 21, 22 should do. If I've got just a little bit more gain to give me some headroom, then that's perfect. So 680 ohms is what it is. Well, now all I have left to do tonight is to put these wires from the emitter resistors to here, but because I'm tired, I'm going to go to sleep and do it in the morning. I was having a look at the circuit diagram, and I got this optional input capacitor, as I was saying before, over the 15k resistor. Most people use a 680 picofarad cap. I have these axial 470 picofarad caps. I'm going to use those. So I don't want too large of a value there. I know there's not much of a difference between 680 and 470, but I just feel like 680 is a little bit too much. So 470 it is. So I will note that on the diagram as well. That is 470 picofarads. Probably after tomorrow, when I've finished sorting out what happens with components arriving, I will make up the schematic for this, because basically I need to draw 2 of these circuits, and then on top of that I need to draw two of those with some modifications. So there are things here that need to be taken out, things that need to be added, blah blah blah. So Oh, and the bias and PR Rails stuff. I've got stuff everywhere. This is what happens when you're designing stuff, you know, you just end up with notes and drawings and more notes, and that's the way it is, you know. I'll say one thing in hindsight, I wish I had have taken more time designing these boards because, well, for one, I wish I used dual layer board, because I wouldn't have had to use jumper wires and I could have done it all in one strip and it would have been a lot neater, probably a bit smaller too. Secondly, this is really hard to change transistors. It's actually fairly easy to change the drivers, but if I had to change the output devices, it would be an absolute, you know what. Um, so yeah, and also those resistors are hard to get to, and you have to take off the links to get to that. So it's a bit of a pain in the ass, but it's all right. I can't complain in terms of performance. You've got, you know, the straightest, shortest path possible almost between components. Everything's, you know, either a thick link or a really thick trace, so there's absolutely minimal inductance. You know, the choice of devices on there is just amazing. So in terms of performance, yeah, it's going to be absolutely wonderful. I wish I had have spent more time on those boards, and I wish I had have waited until I had really thought about everything, because I've ended up, you know, making changes. Okay, the transistors I had to change, that was because they turned out to be fake. That's not my fault, but um, everything else, I wish I had put more time into it in the first place. But anyway, lesson learned. This is an amplifier project I did start on a few years ago, so I did mention in the first place I haven't played with amps for a few years. Also, things will come back to me as I start on it, so there is that. I was just reading a forum post about these resistors on DIY Audio. Yes, these have arrived. And what I saw inside some that were pulled apart was absolutely, I don't know whether to say horrific or hilarious, but anyway, I'm going to have to do my due diligence. Unfortunately, it sucks, but I bought them from AliExpress, so okay, so that was real. Wait, just a film. Oh no, that's right. All right. Let's try the second 0.22 ohm first and see if it's the same metal film construction. Okay, it feels like it is. Now, I haven't pulled one of these apart before, so that's why I'm having a little bit of a look. Yep, no, that's the same. That is some nichrome resistance wire, sort of pulled up, slightly different fashion. This resistor is better than this one, which interestingly enough is the one I'm using in my amp, the better one. Alright, let's see if these 4.7s are. These are the ones I'm really suspect on, because as you can see, they're a different form factor, but that just could be because they're actually real and there's more in there, you know? So we'll just have to see. Oh, I got diddled. I got diddled on these ones. So this is what I wanted to show you guys. Oh my god. Wow. Asians are doing bloody everything they can these days. That's 4.7 ohm, and that's supposed to be 5 watts. There's no way that's 5 watts. Also, that's not non-inductive. That's just wire wound. That is hilarious. You know what? Let's go get a 5 watt resistor and pull it apart and have a look at how thick the wire is. Alright, I don't have a 4.7 ohm resistor that's 5 watt to pull apart. I've got a couple, I've only got 3, I don't want to sacrifice them, so. But yeah, that looks like a 1 watt wire wound job to me. Very interesting. I can order more, I guess. Obviously from a good seller. I really didn't think, oh my God, you know what? I just can't believe this. We're counterfeiting resistors? Really? It's gotten to the point that we're counterfeiting resistors now. I mean, I can understand, you know, the high tolerance and all that sort of stuff, types. People trying to make more money like that. But, I mean, this, I don't know what to say. I don't know what to say. That is just insanity if you ask me. I'm just going to go put this in the bin. I'll be back. Alright, well, I suppose I won't be using these for my amp. I just knew something was off about them. They just don't look right. And when something doesn't look right, it's usually not right. Ah, goodness. I'm going to do some destructive testing on these at the end of this video and see just how much they do handle. And I want to see, you know, how much the resistance changes with heat and stuff like that. So I got the capacitors, the correct capacitors have arrived. I'm still waiting on the polystyrenes, but I've got these 4.7 mic MKS. I did also get 4.7 mic MKPs, as I mentioned earlier. My apologies, my component drawer's jammed. So I got these as well. Now, they do perform really well, like these. They're a lot smaller, obviously, but they're also a lot smaller. Now, I could go all the way and use this, but as I said before, it's already got, you know, all of this across it. So, I don't think, you know, it's going to make too much of a difference. If it was just a couple of transistors with a cap in between them, yeah, I would go for the higher quality cap. But because there's other stuff there in the circuit too, you know, I think the other stuff can cause more distortion than the cap. So I just don't think it's too critical, but I could be wrong. Who knows? Looking at fitment, yeah, that's a bit of a squeeze. I could do it, but again, it just belongs. Let's get the LCR meter, give them a quick test. I just want to see how close to unmeasurable the dissipation factor is, basically. Oops, I went past it. So on the MKPs, I gather it's going to come up as 0. Yep. I mean, these could be 0 too, because they're quite large. You know, it is what it is. Like I said, the MKS 4. I could have a bit better performance with a better capacitor, but I'm just going to go with these for now, I think. I still haven't 100% made my mind up on it. I might end up sticking these in there. I might not. It just depends. I might leave these for an upgrade. You know, I have a plan on replacing the diodes with quieter diodes like Schottkys. I'm going to have to do a lot of work on the millivolt per degree Celsius and all that sort of stuff to get them exactly right. And I'm going to have to add stuff to the string to create more voltage offset because the Schottkys will have a lower forward voltage drop. But when I do that, change all the resistors to carbon in there, I'd probably add that in circuit then. But for now, we'll just go with those. So I'm going to put those in the build bag, ready for the build. That brings me to the next thing. The other day I put these 470 picofarad capacitors in the bag for the input filter. I've been thinking about it, and I had a look around, and I actually have some 300 picofarad, which is even smaller. I'm going to go do some math quickly and work out what frequency gets cut off with that RC network. Let me just get a sheet of paper so it makes sense. I'm talking about your R and C to ground here. The parallel R and C forms a network to ground, but you also have this R and C, but you also have this R and C and this C and R. There's a lot actually going on in an input network that a lot of people don't actually see when they look at it. But yeah, so I'm going to go do some math, work out what exactly is being filtered out with, I think it's 10K and 680 picofarad that I see commonly used. So I'm going to go, and that's for the resistor to ground, the feedback resistor, and this cap. So I'm going to go have a look at what frequency that cuts off at, and have a think about why that might be, do a bit of research. I got a feeling I know it's for high frequency, but I mean it's, probably for RF transmissions and stuff like that. So I'm going to go work out what I feel is a comfortable value and then come back and we'll take it from there. Alright, so I got this resistor just sitting here like so, pumping 5 watts through it. Exactly 5 watts. So it is taking it, interestingly enough. It's not low inductance. Even if it can handle the 5 watts, it's still fake because it's not low inductance and it was sold as low inductance. Also, it's trying to copy BPW or whatever the series of resistor that actually exists. So yeah, it's not discoloring, so that's good. It is hot. I have touched it. I mean, that ceramic stuff that they use does dissipate power well. That's the thing. So I guess they can get away with this. All right. I'm going to put the camera in a tripod. All right. Now what I'm going to do is I'm going to get my multimeter in ohms, and I'm just going to unplug this and just pop it straight in my multimeter as quickly as possible. We're up at 5.6 ohms, but we don't seem to be falling that quick. Oh, yeah, okay. Down to 5.5 now, 5.4, 5.3. Yeah, see, this is what I had a feeling, because that's a really thin wire in there. The temperature coefficient on it's just atrocious. So these resistors are actually in spec, at ambient temperature, but because of what they've done. So no, that is not a 5 watt resistor. If you try and run it even at say 4 watts, it'll end up being a different value resistor. So there you go. The Chinese think they got away with it. Hey, it dissipates the power, it's not popping. Yeah, there's more to it, guys. That's why those other resistors that you saw, the lower resistance ones, had that thick nichrome element that's like a film. It's not a film, it's actually a piece of metal, but you know what I'm saying. Anyway, well, that concludes that test. So, I mean, I would call that a 2 watt resistor. I mean, honestly, it's really only a 1 watt resistor. The thing is, the hotter it gets, the more its resistance will change. So, I mean, yeah, the package can dissipate a bit more heat. You know, it's probably a 1 watt resistor, maybe call it a 2 watt. I don't know. That resistor did look quite small in there, but it was wire wound. I think that is a 1 watt resistor. You know, that's just, yeah, unbelievable to me that resistors are getting faked. I mean, I did some reading up on this, and apparently it's a common thing that goes way back in the day. It's not unheard of. I just can't believe that someone would waste time on something like this. So we'll get into this in a sec. Before I go on with this, yes, I am going to look on like DigiKey and Proper Places and stores that I know on AliExpress don't sell fake stuff, and see if I can find a different version, because you can only get these. One manufacturer offers them up to 1 ohm, another manufacturer makes them up to 2.2 ohms, which makes sense if you think about it, because that element's got to fit in there. 2.2 ohms, it's already probably doubled over, you know. So yeah, these 4.7 up to 10 ohms, 50 ohms, 100 ohms that you see online, they're definitely fake. I thought 4.7 might be low enough to be real, so I bought them, but turns out no, they're completely fake. So what my solution's going to be? Well, I think I'm just going to make it out of a different type of resistor, either a metal film or a carbon film. I may use metal film here. My thinking on this is it's a low value, so it's not going to have much inductance to it. Secondly, there's already an inductor here, so no matter how low inductance the resistor is, you always have the inductance of the inductor. I mean, there's supposed to be inductance here, so I don't think, you know, a low inductor resistor is going to make a huge difference in this application. Although the two inductances will have different resonating points. So, you know, if you consider that, yeah, maybe. Let me go work out how I can come up with 5 watts roughly at 4.7 ohms. I'll be back in a moment. Let's take some measurements. Alright, let's measure inductance, and for shits and gigs we'll measure this one too. Start off with the crappiest one. We'll measure at 100 kilohertz. .276. I don't know what to say there. I really don't know what to say there. The fake wire wound's got less inductance than the real wire wound. That is bloody odd. Considering that should have smaller wire, that really doesn't make sense. Or not should, it does have smaller wire. Anyway, let's continue. Yeah, see, carbon film, like I said, it's going to have nothing. Although, you know what? I've got the lead length there. Let's get rid of some lead length. 040. 0.040. What? Really? Really? Huh. Well, these blue resistors, these metal film, are 2 watt. I would be fairly comfortable putting 4 watt worth there and just using that. Okay. All right. You know, I really don't know if there's a point in doing this. I'm going to do it anyway because we're going high end, but I'm just saying. I've got to go get another 4 of those. Those are 10 ohms, so I'm just going to put 2 together. These are 2 watt resistors, so that's 4 watts there. All right, that's the 10 ohm resistors. So it'll be banks of 2, 4 watts. I don't think they'll ever be dissipating that anyway, so it should be fine. But yes, I'm gonna go fit them now. And actually, you know what, before I get carried away doing that, I'm going to do what I said I was going to do a minute ago and work out this input capacitor value. Alright, I'm not 100% certain on this, but as far as I can tell from doing the calculations on a lot of different amplifiers I've just looked at with the different value of resistor and capacitor, it always worked out to be around 20 kilohertz or 100 kilohertz, which I think that's what's going on. It's forming a high pass filter, low pass filter, sorry. I'm going to put 100 picofarad across 15k because that works out to around the 100 kilohertz, which is 5 times the bandwidth of the design for the amplifier. If you're building a really good amp, that's usually what you do. I happen to have 4 100 picofarad 50 volt caps, which is just perfect for the job. There'll never be more than a couple of volts across that, so I took the other ones out, didn't I? Yep. Into the bag they go. They all went in there. Yep. Alright, so I'm going to fit these resistors to the heatsink now. Geez, this is getting full of nice and colourful components. I'll tell you what, these amps are going to look pretty when they're done. A lot of different colours. Nice, thick components, thick traces. Going to be good. I've formed the leads up on these resistors now, so I'm going to fold them over and take those out and replace them with my new low inductance solution. And I think that's going to be it for today, well, on this, because I can't do anything else until I receive the polystyrene capacitors, which still have not arrived yet for the compensation. I might just leave that for the next video because as soon as they arrive, I'm going to start putting these together. So I think I'll get these fitted now and then conclude this video. But you all can tell what's going on here. Basically, I'm taking this thing all the way, and even when it's built, see, the reason I don't want speaker protection, safe operating area protection, all that stuff added on it now, I want to build an amp that makes, you know, really good quality. I want to test it, change a few things around, see if I can improve it even more, and then I want to add all those extra bits of circuitry to it. That way, if THD goes up or noise floor goes up or slew rate goes down, anything happens, I know it's from something I've added and I can work on it to get it back to how it was. If I go and add all that circuitry to it now, it's just going to be a head F, you know, trying to work out what exactly is causing what. So I think, yeah, this is what I'm going to do. I am going to take this all the way. I always have wanted to do 2 things: repair things, and I've got a bit of a passion for audio, design amplifiers. And, you know, this is something I started on a couple of years ago, built a prototype with one of these heat sinks. It went amazing. I then started building a couple more, but I never finished them. And now I've basically gone back to start on those that I never finished. But as I've gone along the way, I've sort of decided to just go all the way with it, you know? And in terms of quality, components, design, all that sort of stuff. So, you know, it's a bit of a annoyance to me that I didn't decide to do that in the first place, but better late than never. Yeah. Anyway, I don't think there's anything else you could really do other than, like I said, improving the BIOS network to maybe a VB multiplier or Darlington VB multiplier or better diodes with maybe some snubbers on them or something like that, which is actually something I'm going to look into as well. Actually, I'll get these resistors mounted and then I'll look into that, because that might be another solution for any potential noise caused by the diodes, and I'd be happy to look into that. So I'll get these resistors fitted and then I'll have a look into potentially adding a snubber to the diode network. Alright, I'm just going to drill these holes out that I've cleared so I can fit the new resistors, and then I'll give the board a bit of a clean up. Alright, I've opened all the holes up to 1.2 millimeter. Let's see if that'll fit. Yes, that fits. Okay, cool. Alright, I'm going to get these installed and we'll come back. I've still got to install those emitter wires, that's right. I've got to do that. I still need to tighten these coils up. So coils, emitter wires, clean circuit board. Alright, I guess I do still have a couple of things to do. I'll get these resistors done. Alright, I've got those resistors fitted. I'm going to address these coils now. Now, I was thinking about gluing them together, but to be honest, I got these cable ties that I bought recently, and they're quite small. You know, you get your wide, thick cable ties and you get your little skinny ones. Well, these are the skinny ones, and I mean, you know, they're almost as big as the windings themselves. Let's see what these do. Might need two of them. No, one should do the trick. I'll put one on the top and one on the bottom. I don't think it really needs one on the top and one on the bottom, but I just want the coils to not be able to move. The last thing I want is them changing their inductance whilst the amp is running, because, you know, they're not tight. I'll get the rest of this done off camera. Let's see, do I need? No, because the coils are so stiff and the bottom can't move because it's held together by the wire. So no, I just need to tie the tops. So I'll just quickly do these two. Same thing. Ooh. I'm collapsing the coil. That is a slightly thinner gauge coil on this amp. I can keep it tight together from the bottom, however. It's just the top that I don't like the shape of. You know what, I'm going to take this out and try and straighten this coil up by hand. Alright, I got those done up. It took a little bit of fiddling around to get these ones satisfactory, but I did get there. So now I've just got to install the wires that go from the junctions of the emitter resistors over to here. So from those two pads. Actually, how does this work? Yeah, so we go from one pad to here. Hold on a sec. Yeah, these are two outputs. So speaker output 1, speaker output 2. So yeah, these pads here will go one there, and the other side will go to there and there basically. So I'll go cut up some wire now and I'll get those installed, and then after that, I think what I'll do is I'll flow some solder where I'm going to connect wires. Oh, no, it's alright. I just don't want to have to clean the PCB again when it's in situ, getting installed. So I think it'll be alright if I'm really neat with my soldering and I don't make a mess. I don't flow flux everywhere, it'll be alright. So yeah, I'll just get these wires installed and then I'll clean up the PCB and then we'll take a look at it. But that will be the output stage complete. You know how I had problems with gain? I've been looking at this circuit. I know this is me interrupting my work, but I've got this off to the side and I was just looking at it for a moment. And this 470 ohm resistor, look, I know I did try going up to about 2K, and didn't notice any difference, but I can't help but wonder. The other thing that worries me is that this transistor has nothing between, you know, it's between the 0 volt rail and the minus 63 volt rail, so that's, you know, unlimited current. It's got nothing apart from a 100 ohm resistor on its collector, and then it's got this 470 ohm from the emitter to the negative rail. That could try and sink an awful lot of current. I'm a little bit confused about how that is even possible on 35 volt rails, to be honest. Definitely going to have to look at that. Definitely going to have to look at that. I decided, because I am running higher voltage rails, to change those resistors from the 470 ohm to 2.2K. And I am also putting those fast transistors that I changed from the C3200s to the C1845s. I'm going back to the C3200s. It's bugger all difference. They both have the same power dissipation, just one part is 100 milliamps collector current, the other one's only 50. I just feel more comfortable with the 100 milliamp part. I'm not so happy with the gain on them because I'm going from 430 to 228, but I mean, 100 milliamp part still feels a little bit small here. So it is what it is. I might have to get different ones out the drawer. I'll get these matched as good as I can. I might have a look around and see what other transistors I've got. The thing is, I'm trying to keep, especially the first transistor, I'm trying to keep it really low cob, high FT, all that sort of stuff. At the same time as, you know, I need a little bit more collector current than 50 milliamps, so it's a little bit hard. I can't do this whilst I'm talking. I'm going to do this off camera. I'm going to do this off camera. Alright, I did some thinking about this. I ended up putting the 1845s back in here. They're only 50 milliamps. What I did was I upped the resistor to 2.2K, and because it's now in a gain section and it's a higher resistance, I've gone to metal film now. I think what I'm going to do is, if I have problems with this transistor popping, I'm not going to go to the 3200, which is 100 milliamp part. I'm going to go to something bigger, like 401, 5551 territory, something like that, you know what I mean? I'm not too sure yet. We're just going to have to see. I'll take that as it comes. So I'm going to call it done in terms of component choice finally. I have gone over this a number of times. I've revised all my resistor types and values, capacitor types and values. The transistor selection itself is quite nice. I'll get the data sheets up because I said earlier on I was going to show you some data sheets. Let's put these off to the side and I'll show you the data sheets. Alright, so these nice looking transistors are what I've chosen as my, I'm going stupid, the VAS transistor. So typical 150 megahertz, probably a lot quicker than that. HFE's up there. It's only a 1.5 watt part, 100 milliamps. So like I said, it looks big because of the package, but it's not. If you look at the frequency characteristics, the capacitance is really small. So, it's good switching times. Small reverse transfer capacitance and excellent high frequency characteristic. There you go. So that's a bloody nice transistor. The drivers, I am using these. I don't have a good data sheet for, I guess they're both alright. Yeah, they're both Hitachi data sheets. So I'm using these for the actual drivers, pre-drivers, sorry, not drivers. The drivers are MJ15033 and MJ15032. Or was it MJE? Anyway, these are the pre-drivers. These are also fairly small. Collector current 100 milliamps. Power dissipation 1.25 watts. Let me just double check that I've got the right parts up here because something just doesn't seem right to me. These are both the same size of part. What have I done? One moment, sorry guys. Okay, I just took some measurements and had a look at what I got here, and I've confused myself somehow. I don't know what I've done, but these transistors are not the transistors that I meant to use. I meant to use all those other ones. I might keep these separate, seeing as they're matched. Wait, why am I missing one? What is going on here? Huh? What? One moment, please. I swear sometimes I get colorblind. That's right here. I don't know. I thought for some reason I had, what do you call it? 3 of one and 4 of the other. Anyway, those I did not mean to use. I meant to match sets of these, black larger transistors, not these smaller ones. Specifically these. So I'm going to go do that now. I'm going to go match a set of these or 2 sets and fill these bags. I'm glad that I went over everything the last couple of days because there was quite a few things that weren't quite right in here. Alright, I've matched up all those transistors. So now the current source transistors and VAS transistors are the same as the matched sets for the pre-drivers. I don't know how I managed to do that. Very odd indeed. Anyway, I think what happened is when I was reading the data sheet, I think I read one of them as 15 watts and one of them as 1.5 watts or something like that, and I saw the cob difference between the two and I assumed one was a slightly bigger part. I think that's what I did, and then I put the bigger part as the driver. But anyway, these are beautiful transistors, so I'm happy to use them in my VAS. Most people use things like BD135, 136, BD139, 140, MJE, 340, 350, stuff like that, you know. The cob on those is, like 4.5 to 6.5 picofarad. The cob on these is 1.5 to 1.7. Thank you. So yeah, pretty self-explanatory. I'll make these wires up now, solder them in, and I guess that's really it. I might also make up these bars, because I need to make up a couple of bits of buzz bar, if you want to call it that, which basically connect. You see where there's these collector traces. I mean, I could run 4 separate wires back to the cap bank, I think I'll just make a little buzz bar that goes like that, and then the power supply can get hooked onto the bottom of that. So I'm going to make up 4 buzz bars and I think 8 wires. Yes, 8 wires and 4 buzz bars. Get those installed, and then I think that'll be the end of this video. I've got some interesting news regarding Chinese fakes as well. Real interesting news. So I was showing you guys tip 41s with really small dies in them, namely these tip 41s and tip 42s. And I was showing you guys how the tab it always looks the same in all the fakes, and the writing on the front was wrong. Well, I ordered some more tip 41s and tip 42s that have the same sort of design on the front. Yes, okay, it is slightly different, but I mean, that's the same shit. Check this out. That is the correct die size. Also, the inside of the case looks slightly different. So, are these just the genuine copies, or the onsemi actually make them like this as well? Because that would suck. I mean, can you imagine? But I have to say, it is starting to get very confusing trying to work things out. I've got some older onsemi tip 41s I can show you guys. Let's see, where are they? I'll just pause the video whilst I find them. Alright, it turns out I'd actually destroyed them in a video to compare fakes against them, but I do have some other ones that I think are fake that actually look pretty well exactly the same as the real deal. So that's what they look like. You see how the tabs are different style and all that. So the business is different tab, right? However, when we look at the front of the fake one, it looks nothing like it, right? But then when we look at the other one that I just got, that's got the correct size die, it also looks nothing like it, and as you can see, has the wrong tab. So yeah, this is bloody confusing. Anyhow, I will curve trace them all and do testing on them in a very soon upcoming video. As this is a sort of engineering blog of sorts, I feel the need to go over every little detail for people that are learning and interested in this sort of thing. And I've been doing some reading on DIYaudio.com, and I noticed something that got my attention in this VAS area that I'm looking into at the moment. I put a 100 ohm resistor here in the collector. Someone pointed out doing that turns this transistor into an amplifier here, which is essentially multiplying its cob, which is essentially making a capacitor that has a varying value. We don't want that there. So I am going to delete that resistor. No more resistor. All right. I just wanted to let everyone know about that because, you know, I want to be very thorough. So I'm going to go remove, I guess, 400 ohm resistors from my resistor pack now. And I guess I'll put some links in there because I would have made the pads on the board. I'm not going to put any links in there because there's that many components in there with long legs. When I go to make up the board, I'll have plenty of links. So I just took the 400 ohms out. Anyway, now I'm actually going to get this sorted out. Sorry, like I said, originally I started, the goal was, you know, just build a decent amplifier. Then it turned into, you know, the full Monty, all the bells and whistles, and I'm just going over everything and being very thorough, and I'm trying to make sure that you guys are kept in the loop, and anything that I'm doing, whether it's, you know, updating the design before it's actually up and running or after it's up and running, I want you guys to know the reasons why, how it's being done, all that sort of thing, so that you have a window into the design process, basically. Or should I say, my thinking pattern. I don't know how I want to word that, but yeah. Alright, I've been doing some reading online, because I'm kind of concerned about these transistors. The thing is, let me just go get some out the drawer. It'll be a lot easier than showing you off the heatsink. Alright, so I have to take the focus off. There we go. So that one looks original. I don't have a problem with it. That has me very concerned. I mean, like, obviously that is not a non-semi part. It can't be. That's got to be a copy. It has to be a copy. Maybe they're both copies. I've pulled them apart. We've seen the die size. The die is huge. It's the correct size, but it makes me wonder. So what I'm thinking of doing, I have 1302s and 3281s by SPTech. I also have MJL 21194s and 21193s. Now, for what I can tell, they look real. I mean, let's do some quick testing first. Let's see what we've got HFE wise and if they're close, because these parts are usually supposed to be pretty close, I'm pretty sure. I know the 0302s and 3281s are close. That's already a little bit high. Yeah, okay. I think what I should do is do some curve tracing on all three sets and have a look, because these are all very similar transistors, just different power dissipations, but quite similar transistors. So I would imagine the curves would be very similar. And what I'm thinking is, for example, let's say one of these is real, one is fake. Let's say these are both real, and we curve trace them, and the curves for the PNP and the NPN look almost identical, and then we curve trace these and one looks different to the other. You get what I'm saying? I think that's a good way of working out if they're fake. Now I've got that proper transistor tester, we can put some current through them and test VC SAT and a couple of other things. So that could be handy too, but I think before I get this made up any further, I'm going to do this, because I've already decided now, if I do have to take this apart because I've got to change the outputs as well, I will probably end up redoing these boards and going the whole way with it. Dual layer board, all in one strip. Everything that I should have done when I first laid it out. So yeah, let's just see what we get here. Okay, they're all quite close. All right, well, cats. Let's have a look. Let's start with the 02810, the NPN. Let's have a look at VC sat at 2 amps. .33. Let's try the other one. So there's a bit of discrepancy there, but is there supposed to be? I'm not sure which one of these is PNP. Usually the smaller numbers NPN, but I would like to make sure before I risk doing something to them. Okay, that's the PNP. Well, .38. See, that's a lot closer. Okay, let's continue. Better to be safe than sorry. NPN. Through 2. Oh, alas. Yeah, so let's just check these again. How far off were these? 29, 43. These just seem too far apart from each other. I don't like that. And the one that seems to be real or looks real is higher. I'm going to have a quick look at the data sheet. I'll get the data sheet up on the computer and we'll see what it says in the data sheet for VC sat. Alright, in the data sheet it says with half an amp base current, 5 amps collector current, it's around 1 volt. We don't have that option here. But that goes in line with this. This had a higher figure on it. Around, I think it was 0.4, something like that. Yeah, I would trust that and not trust that. I really don't know what to say about this. Actually, if I look at the entire thing, there's actually a difference in the color of the package. I don't know if you guys can make that out, but concerning, quite concerning. Given the die size, I'm not worried. Let's, what other tests can we do on here? Let's check the breakdown voltage on them. What are they supposed to be? Collector meter sustaining voltage. No. There's 1 sec. Okay, it was the same voltage as what I was just looking at, which is 250 volts. So okay. That was the one that looks fake. This is the one that looks real. Don't know what to say. Really don't know what to say there. Was it made in a different factory and it's actually real? Is it, you know, they're both copies but they're fine? I really don't know. Let's do some curve tracing. Let's do what I said I was going to do and do some comparisons. I'm going to curve trace these SPTech NJW3281s and 1302s. The reason being because they're NJW series and they're like the next series up from these. These are MJL, so they're a slightly different series. I think this is more telling. Also, being that they're from SPTech, I don't think these would be counterfeited. I would assume that these are just, you know, from SPTech. But there again, something I'm just noticing now is that even these look different. It's interesting, isn't it? Although different but same. Same but different. Yeah. I think they're legit, you know. But, you know, how do you know? There's so many different fake factories and clones and all that sort of thing. It's just so hard to know. I haven't pulled apart these bigger devices, these 200-watt devices yet. I've only pulled apart these. That's how I know the dies are a decent size in them. So anyway, I'll get these tests done and then I'll come back and we'll have a look and see what we've got. One other thing we can do in here quickly is we can crank up the base current on this. We'll look at 10 milliamps and we'll compare the HFE. Whoops. So that one's 81. So that's pretty promising. We'll just have to see how the tests turn out. I will be back soon. Whilst I'm getting these tests done, I was just thinking something else I can look at. I've just got to swap over the transistor because I've done one. Something else that I can look at. Sorry about that. Something else that we can do is just with a normal multimeter. The capacitance test on the multimeter actually works quite well testing, what am I doing? Capacitance on a transistor, surprisingly. I always get confused how to do it. I wasn't not with a multimeter. Maybe it was with the LCR meter. Hold up a sec. I think it was with the LCR meter now I think about it. Let's just see. We'll do that. Okay. Let me just get the data sheet up for a sec. Wow, those two transistors came out very different to each other. Oh, goodness. Let's just get the data sheet up first and we'll see what we have. So, NJW 8281. Alright, so 400 picofarads. Oh, that's nanofarads. Okay, so I'm testing wrong. Maybe between the collector and emitter. Okay, 500 picofarads. That's I think that's what I used to do. Yeah, that seems a lot more familiar. 700. Okay, at least I'm getting a ballpark figure that way. Let's change the frequency and just see I'm not sure if you can change the bias settings on here or not. I'll have to have a look into that. I'll leave it on 100 kilohertz. Seems more accurate at 100 kilohertz. Well, I've done these transistors, so let's have a look at these. $500. 900. Okay. $600. 800. Alright, well that's usually how it is. NPN is usually different to PNP when you measure the capacitance on them, and yes, quite a bit, especially power devices. And that is roughly the figure that you'd expect to see for power devices. So I don't need to crack these open. I can tell that the die inside them is about that big from that test that I've just done. So if you ever wanted a non-destructive test, that's a good way of doing it. Just looking at the capacitance between the collector emitter junction, that'll give you a really good idea of the size of the die inside. And I'll just prove that a little bit further, just, you know, for people that are interested. So the results I got curve tracing that were not what I expected, so we are going to have to do all of them and see what we get. What have I got here? Alright. Set of transistors. Not sure what pins what on those. Let me just analyze the pin out quickly. Alright. So if we look between the first two pins, that's collector and emitter. And as you see, only 6.6 picofarads. A very small die inside. $14 picofarads, because it's the opposite polarity. So there you go. If you ever wanted to know how to do it without smashing them open, that's how you do it. The reason I smash certain devices open is because I know what the die looks like. That's why I haven't smashed open that or that, is because I haven't actually seen the 200 watt die in real life from one of these components bought from a trusted source. Because I haven't seen a die, I don't see any reason in breaking them open. I've seen those dies. I've seen two C5200 dies. I've seen C3856 dies. I've seen quite a few dies. So I feel comfortable breaking those sort of transistors open to check them. But anyway, I'll just bring that screen up and I'll give you guys a look at what we got. What I'm doing is HFE versus collector current, because it's quite telling usually. So that's the SPTech ones, quite different. I'm not going to save it because we all know what it looks like. You know, one of them's close together, the other one, the lines are quite far apart. So that's the ones I thought were genuine, which probably are. You know, I'm learning here. I don't know the answer to this. If I did, I'd be telling you. I wouldn't be trying to work it out. That's the thing about this channel. If I don't know something, I won't act like a cocky cunt. Excuse my language. I should not have said that. I won't act like a cocky you know what and, you know, act like I know it. I'll discover it on camera with you guys and we'll talk about it together. There's always room in life for more learning. I'm just going to pause the video because I've got to now trace out the next two transistors and I don't want you guys to have to just wait for me. I've only done one so far, but I'm actually quite surprised because it looks quite different to either of these. I think I will actually, after I've had a look at these two, trace all of them out and lay them on top of each other. Or I'll take pictures. Actually, I'll just show you guys, and then you can go backwards and forwards in the video and compare it. That'll make it easy. I just want a way for everyone to be able to have a look at the different graphs. Alright, I've sampled the suspected fakes. I'm going to resample these again. But I'm going to overlay it all. So you won't have to skip through the video. You'll just be able to have a look here. I will show you what these two came out like. So that's what they look like. Now I'm starting the next one, because I want to compare what the different sets look like to each other. Something I've just noticed is when I connected this to the computer, it said that it was the incorrect version of firmware for my software. And when I had a look, this new DCA that I just bought was actually one version newer, so I updated my software. We'll have to take a look and see with a few different components that it didn't do a good job with before, if that's improved with the new firmware. I'm quite curious myself. Okay, well, this next test's already finished up and the results are already quite interesting. I mean, okay, look, they're not the most interesting in the world, but they are kind of inverted, which is strange to me, because these two transistors, or four transistors, two sets of transistors that I've just tested, they are just different power levels of the same device, basically. So you see how the top set here is the lines that are further apart, but here it's the bottom set, the lower HFE transistor. And usually the higher and lower is usually going to be the same. NPN is going to be like the lower and the PNP will be the higher, or vice versa. I forget which way it is, but yeah, I could be wrong there. Like I said, I'm learning here. Let's do the last one. See what we get. Now, if these last two that I tested look similar to each other and different to the first one, that makes sense, because these are 150 watt devices and these are 200 watt devices. Well, the results are in, and to be honest, it's all pretty well the same. I mean, that and that is the first set. That's the second set. Actually, yeah, and this is the third set. So, I mean, yeah. Seeing that and seeing the capacitance test, I'm not going to pull them apart, I can tell you that. I am still really concerned about the legitimacy of these. I mean, I can't see any reason why onsemi would have a full circle around the on instead of the circle made up out of pieces. Let me go have a look around, see if we've got any other onsemi parts. Okay, I know 100% that these are legit, and guess what? On is in a full circle, so that's interesting. Let me go get some more. Alright, I just grabbed a couple more examples. These I got from Jaycar, and again, guaranteed parts. Why is that gone so dark? Oh no, that's not dark for you guys, is it? It's dark for me. My charger was unplugged. Ah, I can see. Right, full circle. Well, there you go. I am a lot less concerned about that now, because the people I bought it from are people I've bought a lot of legitimate stuff from, and I thought that they were a legitimate store, so I think they are. I think they've just got, you know, they bought different batches from different sources, obviously, because they got one batch at a better price. I'd do the same thing probably. Anyway, that concludes that. I've seen enough. I'm going to put these away and finally run these wires. And I know there was something else I had to do, wasn't there? I'll work it out when I get to it. You know, I was just drilling holes here and here on both the heat sinks for the ground wire to go where that Zabel network is. But you know what? I think instead of running buzz bars, I'm going to do it all in wire, but I'm going to make up a wiring harness. So when I go to wire it up, what I mean is I'll run a red wire there, join them together to a single red wire. The same with two blacks going into a single, but it'll all be cable, like a wiring harness, because that will look really nice and it will perform well. So yeah, I'll just leave that to wiring up day and I'll make up a nice little wiring harness for it. So I'm going to put these back over there now because I've done everything I want to do on them. Alright, I'm going to leave it until tomorrow because I've got some components arriving tomorrow. We'll see if those polystyrene caps arrive and then I'll upload this video. Alright, I was going to wait till tomorrow, but I'm just going to show you what I'm basically going to add. Some more of these guys, this value and some other values, but basically that's just going to get added to the bag. The reason why I've decided to end the video today is, well, for one, really all I'm going to do is add capacitors to the bag. Two, that's the last of the parts I'm waiting on to get started on this build. So tomorrow I can start putting this thing together, which means new videos. So I also need space on my phone because I've got other videos to do. I haven't made any videos for a few days, so I'm going to leave this video off here and get stuck into something else. Thanks for watching.